Here's another homework break question for you from our grade 7 math contest. We have a circle that is divided up into 6 equal sections. My drawing is pretty bad, but imagine that these have 6 equal sections. We're then going to color each section either red, blue, green, or yellow, such that we'll have 3 red, 1 blue, 1 green, and 1 yellow. In how many ways can we color this circle using this color distribution? We'll add in one other condition. 2 colorings will be considered the same coloring if you can get from one coloring to the other just by rotating the circle. So for example, if I had red, 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 blue, green, yellow, that's going to be the same coloring of red, 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 blue, green, yellow. So take some time, think about it. How many ways can we color this circle if we ignore rotations? Try actually solving the problem, because then I'm going to give the solution. I'm going to give 2 solutions to this problem. The first, I think, is a little more approachable, but it turns out to be a lot more work. The second is a shorter solution, but it requires a little more insight. So let's consider the first solution. Because we want to worry about rotations, the easiest way to deal with that problem is to just arbitrarily assign one of these individual colors here, blue, green, or yellow, to be the color in this position. So I'm going to say that this is always blue. So no matter what coloring I assign, I'm going to rotate it so that the blue piece is up here in the top left. So essentially, I just have to color the 5 other regions. 3 of them will be red, 1 will be green, and 1 will be yellow. I'm going to represent these 5 regions by 5 dashes. Now, I could, if I wanted to, list out all the possibilities, but to be a little more efficient, I'm just going to essentially think about where do the 3 red end up in these 5 positions. And once I have the 3 red distributed, there's going to be 2 spots left over. One could be green and the other could be yellow. So it could be green and then yellow, or yellow and then green. So basically I'm going to count the number of ways I can distribute the red, and I'm going to multiply that total by 2 to get the final count. To figure out where to distribute the 3 red, I'm going to consider how many of the red are grouped together. So I could have all 3 of the red grouped together. So I could have a red, red, red in the first 3 positions, or I could have red, red, red in the next 3 positions, or red, red, red in the last 3 positions. That gives us all the possibilities where the 3 red are together. Now let's say we have 2 red together and 1 red separate. So I could have red, red, and then 1 separate in the 4th position, or I could have red, red, and 1 of the red in the last position. Those are the only 2 possibilities where I have the 2 red together at the beginning. Then I could have red, red here. Now, I can't put a red here or here because I'll always get the 3 red together. And so the only option with the 2 red in the 2nd and 3rd position is that the other red has to be in the 5th position. Similarly, if I put the 2 red together in the 3rd and 4th position, then the other red has to be in the 1st position. And if I put the red and red together, the 2 reds together at the end, well, then I could have the red being in the 1st position, or I could have red, red, and the red in the 2nd position. The only other option that I have is that we have the red are all separated. And there's only one way to do that. It has to go red, skip 1, red, skip 1, red. So now we have figured out all the ways of distributing the red sections. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And since it could be green, yellow, or yellow, green, we take it and multiply by 2. And so we get 10 times 2 equaling 20 different colorings. Now let's look at solution 2, which is shorter, but takes a little more insight. We will start off in the same way that we started out with this solution, by accounting for the rotations by always putting blue in the top left side here. Once we have that, we have these 5 other positions, okay? And we need to figure out where will we put the green. Well, we have 5 choices for where the green will go. So we have 5 choices for green. Well, once the blue is put in that spot there, and then one of these spots is taken up by the green, then we were left with 4 empty spaces. And from those 4 empty spaces, we'll choose where we're going to put the yellow. So there's 4 choices for the yellow. And once we have chosen where the yellow goes, the remaining 3 spots have to be red. And so there's no more choices for the red. It it is determined by these two choices. So for every choice of green, there is going to be 4 possibilities of yellow. And so we get 5 times 4 equally 20 colorings. We got the same answer as this one here, with a lot less work, but a little more insight. How about you? Did you have a different solution? If so, comment down below.